Welcome, scholars, to Mr. Honeycutt's math class. So today we're working on sketching graphs of functions using factoring and sign charts. And so here's what it looks like. Ideally, by the end of today, you should be able to take a look at this function, factor it, and then building upon the skills we learned last time where we took factored form and then figured out in behavior, x-intercepts, vertical asymptotes, making sign charts, and then sketching a graph from all that. So all we're doing basically on the front end is adding the factoring piece before we do the rest of this. And that all does kind of fit together. Most of what we're going to be focusing on is factoring today is factoring different factoring techniques and things like that. But like this is ultimately where we're going. Yeah. So right now we're just going to focus on finding the greatest common factor. It's the sort of basic thing. But like what I want you to, factoring is all about patterns, okay? And what I've done with the delta math, there's lots and lots of delta math. I'm actually going to do videos, and then you're going to go work on delta math for a bit, and then you'll come back to the videos. I'm trying to force you to make conceptual connections that you haven't made yet, okay? And what we're looking for with the factoring is patterns of patterns. Like I'm going to call them meta patterns or something, okay? And once you start to see these meta patterns, the factoring and honestly algebra in general is going to get very easy. Until you see the meta patterns, the algebra will be absolutely baffling. So let's try some. All right, so here's the pattern. Okay, and I'm just going to do these. So hey, look at this, 54 and 63. Looks like we can factor a 9 out of this. So that should be, that should be 9, and then that's going to be 6 plus 7x. All right, and then next thing, okay, I've got what's common to both. All right, well, a 4 is common and an x is common. So I can pull a 4x out, and then I'm going to have a negative 10 left over plus x to the third. Now, I might have wanted to rewrite that differently, so I might have wanted to rewrite it first. Maybe that would have helped me, but either way, I end up with the same thing basically. Now, for these ones where I've got multiple variables here, well, what variables do they all have in common? Well, it looks like they've all got an x to the fourth in common and a y to the third, which actually does happen to be that thing. All right, so then I'm going to pull out an x to the fourth and a y to the third. And then what's left over? And what you got to remember is, always, 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 there's that implied coefficient. So that's going to be 1 minus x times y. And if you ever get stuck with any of these, remember just FOIL or multiply, distribute it back out, and it should still work. Okay? Same thing here. What do we have in common with all these? Well, we've got this z thing here. Well, that's not really doing anything over there. They both have some x squareds. They both have a negative, so I'm going to have a negative. I'm going to have an x squared, and they both have a y to the first. All right, and then I'm going to pull those other exponents out. So I've taken the negative out, so we're going to have a 7x. Taking 2 of the x's out leaves 4 of them. Taking 1 of the y's out leaves 4 y's. I'm taking the negative out of the 20, so it's actually going to be a positive 20. That's an easy thing to forget, so pay attention. We've taken both of the x squareds out, the y out, so the only thing left is the z cubed. So this should all be basically familiar. But again, I want you to see this sort of pattern of, hey, there was a 9 in both of these, and we pulled it out. There was a 4x in both of these, so we pulled the 4x out. There's an x cubed, y cubed in both of these, so we pulled that out. There's a negative x squared y, so we pulled that out. The same thing's going to happen when we hit this sort of what I'm calling meta patterns. Okay? So notice, hey, look at this. This one, they're kind of giving it to you, but there's a 2x squared plus 7 in this one. There's a 2x squared plus 7 in this one. There's a 2x squared plus 7 in this one. Oh my gosh, guess what? We're going to pull all of those out together. All right? And then what's left over is I've got an x squared. I've got a 16x. I've got a 63. And I can actually factor that some more as well if I want to. That's 9 and 7. So what multiplies to 63 but adds to 16? That's going to be x plus 9 and x plus 7. There will be more about how to do that to refresh you on factoring trinomials, but for right now. Now for here, you can again think of this, if you're getting stuck with this, you can think of this as like an x or a u or something. So that if I had, this would kind of be equivalent to, well, if I had x squared minus 3x, how would I factor that? Well, I would pull out an x, and that's it. And it'd be x minus x times x minus 3. I'm going to do the exact same thing here. I'm going to have 8x minus 7. Make sure you understand those are different. All right, parentheses, and then I'm going to have a leftover 8x minus 7, which would technically be to the first power, but I'm just going to leave it at x. There's the implied 1. I could write it. And then minus 3. And then I could actually clean this guy up just a little bit just because of the x minus 7, the x minus 3. So that's going to be an 8x minus 7 times 8x minus 10, because these are like terms here. But notice this, as different as this might look from this, it has the same pattern as this, the same meta pattern. That's what you got to start seeing. That these units, these things are functioning like x's, and they move as a unit and they factor as a unit. Once you start to see that, life's going to get better. So we've got a similar thing over here. All right, that's my sort of x squared, that's my x. So I'm just going to factor one of them out. I'm going to write this small so I don't run out of room. So 2x plus 7. I'm going to factor one of those out, which leaves me with 2x plus 7 times 2x plus 3 plus, and then this other one has also gotten factored out. So then you could think of this as like the green 2x plus 7, which is one of them, and then this is the leftover one. And then plus 3x minus 2. I could FOIL this out and then clean this up a little bit, and Delta Math might actually expect you to do that, but this is pretty good for right now of what I'm trying to do. Now, also take a look over here. This looks, again, completely different, probably, but I'm going to rearrange this. I'm going to subtract this on one side, and whatever I do to one side, I do to the other. So I'm left with 3 tan x sine x minus 10 sine x. And what do we have in common for both of them? Hey, look, it's a sine x. So what I'm going to do is I'm going to factor that sine x out. Times 3 tan x minus 10. And these are, this would be, by the way, this would have been an equals 0. This would also be equals 0. So then now I've got two factors here. When sine x equals, I can split this because of the zero product property. And then when 3 tan x minus 10 equals 0. So then that's going to be, hey, when is tan x equal to 10 thirds? And then when is sine x equal to 0, which is pi, negative pi, or positive pi, so on and so forth. I think on the actual Delta Math, it's in degrees. So you might have to like bust out some sort of online calculator for this piece, but notice what matters is this same process of the factoring, the meta pattern. So the meta pattern, just say, is we've got some object here that is common to all, to both of these things, and then I could factor it out. Or if I have more than one, you know, I could have up to 3 things or 4 things or 5 things. It doesn't matter. I'm going to factor all of those things out so that then this is all that's left over. All right? And this is like for any sort of greatest common factor sort of thing, this is the big pattern. And once you start to see these sorts of groups and stuff, you're not just looking for what variable do they have in common, but what thing. Okay? It could be a grouping, binomial, whatever. It doesn't really matter, but it's like that's what you're looking for. And yeah. So look for that on these types of problems for the Delta Math.